NASA, the agency that put men on the moon, now faces something no budget crisis ever threatened: a potential shutdown triggered not by politics, but by 3I/Atlas, a cosmic anomaly breaking every rule in the book. Discovered in July 2025, Atlas weighs an unheard of 44 billion tons and sports a tail that bends against the solar wind, pulsing with bursts of brightness no comet model can explain. As Congress demands answers and funding hangs by a thread, suspicion grows that NASA knows more than it's admitting. What happens when a single object in deep space threatens the future of Earth's most storied space agency? The answer may force us to question everything we think we know about truth, secrecy, and survival. Every October, a handful of lawmakers gather in a windowless Capitol subcommittee room to decide the fate of NASA's next year. These hearings, commerce, justice, science appropriations, are routine, even dull. The agency's budget, just over $25 billion in 2025, is usually debated alongside fisheries, census surveys, and the FBI. Most years, negotiations center on percentages: $1 billion here for Artemis, a cut there for Earth science. Delays are common. In 2018, a government-wide impasse forced NASA to furlough 97% of its workforce for more than 2 weeks. Mars rover teams worked without pay, and mission control lights flickered on skeleton crews. The 2010 to 2019 standoff brought a second partial freeze, halting new contract awards and sending scientists home mid-experiment. But these shutdowns were side effects, collateral damage from budget battles that had nothing to do with the cosmos. The process is fragile by design. NASA's funding flows through annual bills, each subject to last-minute amendments, political horse trading, and the threat of a presidential veto. The agency has no independent revenue stream. When Congress stalls, NASA waits. When a bill passes, the money arrives in monthly installments, never guaranteed, always provisional. This system, built for accountability, leaves the agency exposed. A single appropriations rider can freeze entire programs. A committee report can demand new disclosures or halt data releases. In the past, these levers were used to punish cost overruns or settle partisan scores. Never before has a line item referenced a comet by name. Now, the calculus has changed. For the first time, a cosmic discovery, 3I/Atlas, sits at the center of appropriations debate. Lawmakers cite its anomalies in floor speeches, attach conditions to NASA's funding, and threaten immediate suspension if answers aren't forthcoming. The usual procedural safeguards, hearings, markups, continuing resolutions, have become weapons in a new kind of confrontation. The agency finds itself navigating a maze where every step is watched, every dollar contingent on transparency. The old rules of budget brinkmanship no longer apply. What began as a scientific puzzle has become an existential test for the institution itself. A single interstellar object flagged by the Atlas survey on July 1, 2025, has detonated every expectation built into comet science. The first anomaly, mass. Early estimates based on brightness and outgassing hovered near 1 billion tons. By August, JWST and Hubble data forced a 10-fold revision. Now, the nucleus weighs in at over 44 billion tons. That's more than triple the mass of any known comet, with a diameter exceeding 3 miles. The numbers alone would be enough to rewrite textbooks, but the surprises multiply. Imaging teams tracking the tail watched as it bent, not away from the sun, but at times against the pressure of the solar wind. Standard comet models can't account for a dust tail resisting the force that shapes every other comet in the solar system. Some suggest magnetic fields or jets, but the geometry doesn't fit. Photometry logs add another puzzle. Instead of a steady fade or slow brightening, Atlas pulses. Its brightness surges in near-perfect intervals, every 5 to 8 hours. These rhythmic flashes don't match any known rotation or breakup pattern. Deep stack images from Gemini North and Pan stars hint at faint companions. Not debris clouds, but discrete, persistent objects moving in formation alongside the main body. No comet has ever displayed coordinated fragments like this. Thermal readings from JWST show heat emissions that exceed what should be possible from passive sunlight alone. The core seems to radiate from within, hinting at a hidden energy source. Each anomaly by itself might be dismissed as experimental error or a rare outlier. Combined, they have fractured consensus. NASA's own scientists are split, some doubling down on exotic natural processes, others whispering about artificial origins. The data refuses to settle, and with every new observation, the questions multiply. Pressure arrives not as a broad threat, but as a barrage of pinpoint demands. On July 18, 2025, the House Science Committee delivers a formal letter to NASA headquarters, 12 pages, single-spaced, each paragraph a question. The committee wants raw telemetry from every Atlas observation, including timestamps, instrument logs, and original calibration files. They call for the full chain of custody on data handling, naming specific servers and personnel. No summaries, no redactions. The focus sharpens further. Lawmakers reference a sequence of communication dropouts logged by Mars orbiters in late July. They ask for the exact packet loss rates, transmission delays, and internal incident reports. The committee cites discrepancies between NASA's public statements and technical bulletins posted by independent observatories, pressing for reconciled logs and explanations for any mismatch. They demand access to the Deep Space Network's master logs for the period when Atlas's brightness surges were first recorded, including all error codes and maintenance records. Subpoenas follow. On July 25th, NASA's legal team receives binding orders to produce unedited Deep Space Network records covering a 72-hour window, plus all internal emails mentioning Atlas or unexplained telemetry. The language is clinical, but the intent is unmistakable. Oversight members want to trace every byte, every decision, every delay. Congressional staffers schedule forensic reviews, requesting NASA's IT security protocols and audit trails for the servers that store Atlas data. The questions pile up. Why were certain Mars rover signals flagged as incomplete? Who authorized the removal of diagnostic data from the public archive? Why did 2 external astronomers report light curve anomalies before NASA acknowledged them? Each demand lands with the weight of institutional authority, backed by the threat of budgetary consequences. There is no room for negotiation. The pace is relentless. NASA's compliance is no longer optional, and every answer is now a matter of public record. Congress holds the power to halt NASA's momentum with the stroke of a pen. The most direct weapon, appropriations riders, short clauses tucked into the annual funding bill. One line can suspend the release of billions in operational funds until NASA delivers unfiltered Atlas data. In the draft for fiscal year 2026, a single paragraph freezes all planetary science outlays, citing pending compliance with oversight requests related to Interstellar Object 3I/Atlas. Budget holds are only the first lever. Language in committee reports goes further, authorizing the suspension of active missions if NASA fails to meet disclosure deadlines. Under this framework, Mars operations, deep space tracking, and even flagship observatories could be paused indefinitely. Letters from the House Science Committee reference past precedents: climate research in 2017, classified satellite programs in 2010, where funding was withheld or redirected until agencies complied with congressional demands. A more severe option sits in the fine print: temporary transfer of operational control. If lawmakers determine that Atlas represents a national security concern, they can strip NASA of independent authority over the Deep Space Network, shifting oversight to the Department of Defense. Proposals circulated in late September outline the conditions for such a move: classified annexes, notification protocols, and real-time monitoring by intelligence agencies. For NASA's leadership, the threat is not abstract. Closed-door meetings feature blunt warnings: comply, or risk losing access to the very infrastructure that makes deep space science possible. Each of these steps is on the table. The agency's future now hinges on the willingness of elected officials to pull these levers. For the first time, the machinery of government oversight is trained not on cost overruns or missed deadlines, but on the handling of a single enigmatic visitor from beyond the solar system. Avi Loeb, chair of Harvard's astronomy department, steps in where NASA's official voice hesitates. By mid-July, his public blog posts and early draft papers circulate through academic networks and congressional inboxes alike. Loeb doesn't hedge. He points to the mass: over 44 billion tons, far beyond any comet on record. He highlights the tail, bending in ways that defy solar wind physics. He notes the rhythmic pulses in brightness, the possible companions, the heat readings that hint at something more than sunlight at work. In interviews and open letters, Loeb frames these as not just anomalies, but potential signatures of engineering. He floats the hollow interior hypothesis, a shell, not a snowball, perhaps even a vessel. On August 2nd, a preprint co-authored by Loeb appears online, arguing that the tail's behavior is consistent with controlled outgassing, propulsion, not passive venting. He calls for all raw data to be released for the scientific process to unfold in public view. These arguments ripple outward. Harvard's willingness to speculate, to publish before the dust of consensus settles, stands in sharp contrast to NASA's guarded statements. Congressional staffers cite Loeb's papers in oversight memos and floor speeches. The contrast is stark. Academia as open forum, NASA as gatekeeper. Loeb's approach emboldens other researchers to speak up, and his visibility makes it harder for lawmakers to accept technical obfuscation. The credibility contest is no longer confined to laboratories and mission control. It's playing out in the headlines, in committee rooms, and on the public record. The catalogue of interstellar visitors is short, but each entry has rewritten the rules. In 2017, Oumuamua arrived with a trajectory from outside the solar system and a behaviour no one could explain. Its light curve twisted, its speed increased as if pushed by something more than sunlight. Theories ranged from hydrogen icebergs to artificial sails, but no consensus stuck. 2 years later, Borisov crossed the sky, a true comet, hyperactive, but still within the boundaries of known chemistry and physics. It vented cyanide and carbon monoxide, shedding mass at rates higher than most solar system comets, yet nothing about its path or structure defied expectation. Atlas is different. Its mass sits at over 44 billion tons, dwarfing both predecessors. The tail bends against the solar wind, a direction that breaks the framework of comet science. Rhythmic pulses in brightness, companions moving in lockstep, and heat radiating from the core have forced even cautious astronomers to revisit first principles. Each anomaly challenges a separate pillar of comet theory, but together they form a pattern that can't be dismissed as coincidence or error. Within the scientific community, the escalation is impossible to ignore. Oumuamua hinted at the strange. Borisov offered a reassuring return to normal. Atlas collapses the gap, combining every red flag into a single, undeniable event. The sense is not just of a new object, but of a turning point, a visitor so anomalous that the old explanations no longer hold. Deadlines multiply in the shadows. Each week a new document surfaces, a redacted email chain, a snippet of internal chat, a spreadsheet with timestamps and instrument codes. The source is never named, but the rhythm is unmistakable. Every Friday, another leak lands on a science blog or in a journalist's inbox. Time to catch the weekend news cycle off guard. The pace accelerates as September wears on. Congressional aides track these releases, cross-referencing each with NASA's official updates, searching for gaps or contradictions. The leaks are rarely dramatic in isolation, a calibration note here, a missing log entry there, but together they sketch a picture of an agency under siege from within. Behind closed doors, NASA's legal and communications teams scramble to prepare for the next oversight review. The calendar is unforgiving. October 1st looms as the date when appropriations committees reconvene, with the authority to freeze funding at a moment's notice. Staffers circulate draft responses and rehearse talking points, aware that any misstep could trigger a shutdown order. The pressure is not just external. Whistleblowers, some from deep within the Planetary Science Division, push out information at a steady clip, bypassing official channels. Their motives remain unknown, their identities carefully shielded, but their timing is precise. Each disclosure lands like a warning shot, counting down to a decision point that draws closer by the hour. The effect is cumulative. Every leak chips away at NASA's ability to control the narrative. Tension builds in meeting rooms and mission control centers, where scientists and administrators wait for the next document to drop, knowing that the margin for error has vanished. Neil deGrasse Tyson, standing before a wall of swirling comet images on cable news, keeps his verdict measured. It's a puzzle, not a panic. Let's focus on the observation. He points to the numbers, mass, tail, companions, and calls them outliers, not omens. The real risk, he says, is jumping to conclusions faster than the data allows. Across the studio, Michio Kaku draws a sharper line. If even a small fraction of this is artificial, the implications are astronomical. He sketches a scenario where a shell of engineered ice, pulsing with internal heat, drifts between the stars. For Kaku, the tale's defiance of solar wind is not a quirk, but a clue. The conversation swerves between physics and philosophy, each sentence raising the temperature of debate. Avi Loeb, never far from the spotlight, leans in with a challenge. It's time for bold hypotheses and bold disclosure. His blog posts rack up thousands of comments. He calls for the raw data to be opened. No embargoes, no summaries, just the numbers. Loeb's words land in congressional hearings, in late-night science panels, and in the inboxes of NASA's press team. The agency's official statements grow more cautious as the noise outside grows louder. 3 voices, 3 futures. Tyson's caution, Kaku's speculation, Loeb's demand for daylight. The questions hang in the air. If Atlas is natural, why does every measurement strain belief? If it's not, who decides when to say so? And if the truth lies somewhere in the noise, how long before the world demands an answer? In July 2025, 3I/Atlas was recorded with a mass near 44 billion tons and a tail bending against the solar wind, an anomaly never documented before. Congressional committees responded by issuing subpoenas for NASA data and threatening a budget freeze, marking the first time a single interstellar object has triggered an operational shutdown threat for the agency. Harvard researchers openly questioned NASA's explanations, pointing to heat emissions and coordinated companion objects that remain unexplained in public reports. As of September 2025, multiple key Atlas datasets are still classified, and oversight deadlines loom. While prior shutdowns were caused by political gridlock, this standoff centers on unresolved scientific evidence and demands for disclosure. The core facts are clear. Atlas has exposed deep institutional divides, and the official record is incomplete. Until all data is released, the true nature of 3I/Atlas and why it brought NASA to the brink remains an open question.